Okay, so these are notes for 3.4. So first we're going to talk about solving quadratics using square roots. So we're going to start by solving the quadratic. We've got 5x squared minus 20. We're trying to get x by itself. So the first thing we need to do is move the 20 to the opposite side. So we are going to add 20 to both sides, just like we're solving for a variable, a regular variable. We do addition, subtraction, then multiplication, division. Okay, my next step then, get rid of the number in front of x. So I'm dividing by 5. And I end up with x squared is equal to 4. So what I'm going to do is take the square root of x squared. And if I have to square root the left, then I'm going to go over and square root the right as well. So the square root of x squared is x. And the square root of 4 is, and the square root of 4 is going to be equal to plus or minus 2. Okay, for the next one, solving it the same way I did before, move the number over first, so I'm adding 5 to both sides. I end up with 3x squared is equal to 30. And then I am going to divide by 3 to get the x by itself. So x squared is equal to 10. And then finally I am going to take the square root. Okay, so square root of x squared is x, and then the square root of 10 is not going to end up being a whole number. So we're going to leave it as plus or minus the square root of 10. And then finally, the last one, I'm going to start by, again, adding the 36. We're trying to get the x by itself, so we're moving the number over. So 2x squared is equal to 36. I divide by the number in front of the x squared to try and get the x squared by itself. So I end up with x squared is equal to 18. And when I take the square root for this one, I get x is equal to the square root of 18. But the square root of 18 can actually be simplified. So the square root of 18 can be broken up into the square root of 9 times 2. And what we're doing here is we're looking for a square root, a perfect square that is in this number that can be divided out of this number. And so the perfect squares are 4, 9, 16, 25, 36, 49, 64, and so on, okay? And these are perfect squares because the square root of 4 is going to give me 2. The square root of 9 will give me 3. The square root of 16 will give me 4. They give us a whole number. So 18 has a perfect square in it that we can divide out of it, and the perfect square is 9. So then I take the square root of 9. I can split this up into the square root of 9 and the square root of 2. So I end up with the square root of 9 is going to give me 3. The square root of 2 we leave as the square root of 2. We cannot simplify that any further. And of course it's going to be plus or minus. Okay, so what are the solutions of the quadratic equation? What we're going to do is we're going to factor the equation like we did yesterday. So we're going to start by setting up 2 parentheses. And remember, we're looking for the numbers that add to be -5 and multiply to give us 6. So we're going to list the factors of 6. So the factors of 6 are 1 and 6, 2 and 3, -1 and -6, -2 and -3. And it's important to include these negatives here. Since the number in the middle is a -5, that means my numbers are going to have to be negative. Okay, so, and one by one I'm just adding these together now. 1 plus 6 is going to give me 7. 2 plus 3 gives me a +5. -1 plus -6 gives me -7. Negative 2 plus negative 3 gives me a negative 5, so those are my numbers. They multiply to give me 6, and then they're going to add to give me that negative 5. And I plug them in now. So I break my x squared up into x and x, and it's going to be x minus 2 and x minus 3. So this is what we did in a previous class. So what we're going to do now, this equation is equal to 0. So the zero product property says that I can take each of these and set them both equal to 0 and solve. So x minus 2 equals 0, x minus 3 equals 0. And these are just one-step equations. So I get x is equal to 2, and x is equal to 3. For the next one, we have x squared minus 7x equals negative 12. In order for this to work, we have to make sure all of the numbers are on the same side of the equal sign. So we are actually going to add 12 to both sides. So we get x squared minus 7x plus 12 equals 0. All we had to do is just move that negative 12 over by adding it. And now I can go ahead and set up my two parentheses. And I'm looking for the two numbers, the two factors of 12 that will add to give me negative 7. So my factors of 12 are 1 and 12, 2 and 6, 3 and 4, negative 1 and negative 12, negative 2 and negative 6, negative 3 and negative 4. And the two numbers that add up to be negative 7 then are the negative 3 and the negative 4. So this is going to be x minus 3, x minus 4 equals 0. And then again, setting them equal to 0 individually and solving. Oops. So I'm going to add 3, and I end up with x is equal to 3. Add 4 here, I end up with x is equal to 4. Okay, and then for the last one, this time we don't have 1 in front of the x squared. So first I need to make sure that all my numbers are on the left side of the equal sign. So I am going to subtract that 15 from both sides. So I end up with 2x squared plus 7x minus 15 equals 0. And now we're going to have to do factoring by grouping. So we multiply the first number, the a, times the constant. So 2 times negative 15. And that is going to give us negative 30. And then I'm looking for the two factors of negative 30 that will add to give me positive 7, that number that's in the middle. Okay, so my factors of negative 30 are 1 and negative 30. 2 and negative 15. 3 and negative 10. And I would go on finding all my factors. The two factors that are going to add to give me a positive 7 are going to be negative 3 and positive 10. If you need to, list all of the factors first and then figure out which one from the list is going to add to give you negative or positive 7. So negative 3 and positive 10. So that means I am going to break my 7x up into minus 3x plus 10x minus 15. So all I did was I rewrote 7x as minus 3x plus 10x. And now we group these together, the first two terms and our second two terms, and we pull out the GCF for both of these. So the GCF for the first one, it looks like it's just x. And then I write whatever's left over in the parentheses. And then for the second one, the GCF is 5. So I have a 2x minus 3 left over. Okay, and then I am regrouping here my x plus 5 and the 2x minus 3. And if you weren't here for that lesson, the x plus 5 comes from what's left over in front of the parentheses. The 2x minus 3 is just whatever's whatever's in the parentheses, and it should be the same exact thing. So now that I've factored it, I can go ahead and set them both equal to 0. So x plus 5 equals 0, and 2x minus 3 equals 0. And I solve. So for the second one, it's actually going to be a two-step equation. And this is going to end up giving us a decimal. This is going to be x is equal to 1.5, 1.5, or 3 halves. Okay, so there's a little more to 3.4 that we're not going to cover in this video. We will finish the rest of it in class. So now go ahead and go to Math Excel, review the video again if you need to, and complete the assignment.